very much for being there at all times. My producer is Ninka Adeosho. On behalf of my Director of Administration, Barrister Bolati Toyogi, I say welcome on board. Today, for Senior Secondary School 1, Mathematics, we want to see mensuration. And under mensuration today, we want to see cone. We want to see the relationship between the sector of a circle and a cone. This is a circle, A is a sector, the length of an arc AB, A is the radius, L. Now, let us suppose that the sector is taken out, and A is a sector taken out of the circle. This is the arc length. The next thing, we fold the sector to have a cone. This is the result when we fold the sector OAB, we have this cone. The overlap, B will come on A, so we have to rename. This is cone OBI. And another important thing there is that when this folds, arc AB will now become the base of the cone. So the base of the cone will have its radius. Now this results in length of arc AB is equal to circumference of the cone base. From this, we have this. When this folds, it gives this. So this is an important result. Length of arc AB is equal to circumference of the cone. In other words, talking about this, the length of arc is theta over 360 degree times 2 pi L. L being the radius, as we can see. Now in relation to the base of the cone, then that is 2 pi R. So here we are saying theta over 360 degree times 2 pi L is equal to 2 pi R. This is an important result. Let's pause there and go to the property of a cone. A is a cone, the vertex, the cone, the base of the cone, which is a circle, the vertical height H, the slant height L, the radius of the base, which is R, the vertical angle alpha A. Now let's see. H is the vertical height, L is the slant height. The vertical angle is alpha plus alpha equals to 2 alpha, as we can see here. Then the next thing is we can see that this, and we can see that the Pythagoras law says the square on the hypotenuse side is equal to sum of the squares on the two remaining sides of the right angle triangle. So that applies here to give us that slant height. L squared is equal to H squared plus R squared, Pythagoras theorem. From there, slant height L is equal to root H squared plus R squared. This is also an important formula there. Also, let's look at the formula under cone properties of a cone. The curved surface area of a cone is given by pi RL. The curved surface area of a cone is pi RL. Now, the total surface area of a cone is equal to pi RL plus pi R squared. That is the curved surface area plus the area of the base. When we go with that carefully, the total surface area of a cone is pi R into L plus R. There, L is length height, R is base radius of the cone. So, volume of the cone is 1 over 3 pi R squared H. Let's take note of these. They are very important. Now, question. We have a question here. A sector of a circle of radius 8 centimeters subtends an angle 90 degrees at the center of the circle. If the sector is folded without overlap to form the curved surface of a cone, find the 1. Base radius, 2. Height, 3. Volume of the cone. Take pi equals to 22/7. The very first thing there, solution, we try to make a sketch. A is the sector to be folded. Subtends angle 90 degrees. The radius of the cone is 8 centimeters. This is the length of the arc. When folded, it gives this. So the slant height of the cone is 8 centimeters. This is the base radius. This is the height. So we have that. Now to the property which says arc length is equal to length of the cone base, which we had talked about earlier. So this results in theta over 360 degrees times 2 pi L is equal to 2 pi R. We impute the values carefully. 90 over 360 degrees times 2 pi 8 times 2 pi R. Then since 2 pi is common to the two sides, this cancels this. Then we play around with what are the per se. So radius is 2 centimeters. So the radius, the base radius of the cone is 2 centimeters. Let's be careful with the calculation. That is what we have there. The second one, the height of the cone. Yes, we go to the property. Length square is equal to I square plus radius square, Pythagoras theorem. It had been earlier stated. Then we try to make h square the subject of the formula. Then carefully we have 8 square minus 2 square. 64 minus 4 gives 60. H will now be square root of 60. That's 7.75. We can put that to 1 decimal place. When corrected to 1 decimal place, the vertical height is 7.8 centimeters. And lastly, the volume of the cone. The volume of the cone is given by 1 over 3 pi r squared h. And that means 1 over 3 times 22 over 7 times 2 raised to the power 2 times 7.75, which is the height. When we are careful with that, we have 32.5 centimeter cube. That's the result. And here we have got list of questions, a list of questions for you to attempt. We have WASC November 1989 number 40, objective there. November 1988 number 40, objective as well. June 2007 number 16, objective as well. For the theory, we have WASC June 1988 number 5, theory. June 2010 number 4, theory. June 2011 number 3, theory. Please, we can get more questions in our textbooks. Thank you very much for being there. My producer is Yinka Adioshi, and on behalf of my Director of Administration, I want to say bye.